Okay, let's go ahead and estimate some square roots because not every square root is going to be that whole number or, that positive, negative number that we were talking about. So when we estimate them, we can do kind of a rough estimation or we can get a more exact estimation. And the more exact estimation is going to be done on a calculator, and we'll look at that in a minute or so. But we can estimate it using what I call a sandwich theorem to think about just kind of roughly what two numbers the square root would lie between. So we're going to think of a perfect square that's just a little bit smaller than your number and write that to the left of the problem. So right here is 27. And I want to think of a perfect square that's just a little bit smaller than 27. And I'm thinking, oh, that's 25. And if you're not sure, just go ahead and get out that perfect squares paper that I gave you, and it has all the squares listed, and you can just kind of look down through at the one that's smaller and one that's bigger. So I wrote it down to the left of the problem. We're going to think of a perfect square that's just a little bit bigger than your number. Write that down to the right of your problem. So 25 and then 27. So 36 would be my next perfect square. We're going to find the square root of each number. The square root of 25 is 5. The square root of 36 is 6. We've written them down below. So my square root is a decimal that's between these two numbers. And I can't say that it's like halfway between because 27 is closer to 25 than it is to 36. So it's closer to the 5th part than it is to the 6th part. Also, here's just a little hint for this. Your numbers will always be consecutive. It'll always be like 5 and 6 or 8 and 9. There won't be any jumping in numbers. So if you can find one of the perfect squares, either the lower or the higher, it's really easy to find the other one just because you can look at your chart and look at the next one up or the next one down, depending on like which one you could identify first. So the square root of 27 is somewhere between 5 and 6, and it's closer to 5 because 27 is closer to 25. So right down here in my number line, I'm just going to put a big fat dot. And the number line isn't super precise. I don't care that this isn't super precise. We're just giving a rough estimate. Let's look at another example here. The square root of 61. So I want to think about a perfect square that's a little bit smaller than 61. And actually, to me, 61, 64, 8 times 8 is 64, jumps right out at me. I just see that immediately, which makes my life easier. I'm like, okay, well, if this is 8, well, then it's got to be between 7 and 8, because remember, my numbers just go right in order. So this is between 49 and 64, or between 7 and 8 on the number line. And since 61 is closer to 64, that means that the square root of 61 is going to be closer to 8 on the number line than it would be to 7. So I'm just going to put that dot roughly closer to 8. I'm not going to worry about it being perfect or not. Okay, so let's look at the situation where I could just use a calculator and I wouldn't have to plot something on a number line. So here's my calculator right here, and I just want to know what the square root of 27 is. If you notice where the x squared button is, right above it is that little square root symbol. So I'm going to hit second x squared, and the square root symbol comes right on my screen. I'm going to type in 27, end my parentheses, bam, 5.19. Hey, that's what we estimated. It would be between 5 and 6 and closer to 5. So we did a good estimation here, and our calculator showed us another more exact estimation. Let's double check this guy. So again, second x squared gives me my square root symbol. And I'm going to type in 61. I'm going to close my parentheses. Oh, 7.8. Yeah, we said it be between 7 and 8, and we said it be closer to 8 than it would be to the 7. 7.8's getting pretty close to 8. So we did a pretty good job.